From South Bend, Indiana, welcome to 3Degrees Discussions. I'm your host, Mike Vasquez. This is a podcast devoted to the stories behind the innovators, entrepreneurs, and leaders shaping the future of additive manufacturing.
What I've been doing over this summer after graduation has been trying to build out those partners and that industrial base that I can lean on to build up that supply chain for drones specifically. And I think there's other industries that can go into very much hand in hand. Especially we're seeing printers being put on that very similar NDAA list that the drones are. So I think that'll be another area where analysis can be done. And
today's guest is Justin Levy, founder of DefendAM, a company focused on strengthening America's domestic drone manufacturing capabilities. Justin's background spans additive manufacturing, defense manufacturing, and unmanned systems development, with experience supporting the Air Force and Navy programs, SBIR and STTR initiatives, and production efforts aimed at building secure, scalable manufacturing for mission-critical platforms. In this conversation, we'll discuss Justin's journey into the defense and additive manufacturing industries and why domestic drone production has become increasingly important. Before we get started, head over to www.3degreescompany.com and subscribe to the podcast. Remember, you can listen to the show anywhere you get your podcasts, including Spotify, Apple Podcasts, or Amazon Music. And if you or your organizations are looking for support with materials, qualification, or general additive manufacturing challenges, reach out to the team through our website or email us at info@3degreescompany.com.
Awesome. Thanks so much for joining the show today, Justin. We're excited to have you on. Former intern of 3 Degrees last summer and kind of back on the podcast here. So for those who may not know who you are, why don't you give a quick intro, kind of where you're from, where you grew up, maybe start with that and see where it goes.
Yeah. Thank you for having me. It's a pleasure to be on the podcast. I'm Justin Levy, a recent graduate from The Ohio State University. I was originally from Los Angeles area, but came out here for school. I was, of course, wanted a big football school, wanted the fun, but really wanted to be able to pursue additive. Got interested in that when I was 13 with my first printer that saved up a bunch of birthday money for. And then ever since then, throughout that time, I started meeting people in this industry and got connected with the group at CDME, Center for Design and Manufacturing Excellence, and was told about a position to be able to start working throughout my entire undergrad career.
What was your first introduction? Do you remember kind of the instant you saw 3D printing back in the day?
Yeah, I think originally it was from Quit.tv, if you're familiar with that, Leo Laporte. One of their shows that they had was like kind of maker type of things, and it was like the XYZ Da Vinci machines that they got one of like the first ones, and we're talking about that, and I was really interested and did a bunch of research, and then found the 3D printing nerd Joel Telling, which many of us know, and watched a bunch of his videos and learned about like FDM polymer printing. And then I found out what different ones I was 13, didn't have thousands of dollars to go spend on a machine, but I saved up a few $100 and was able to, I think I got the Wanhao Duplicator i3, which, I mean, I don't even think that company exists anymore, but was one of the machines that were available at that time in that price range, and learned with that for almost a year. And then saved up money both from I was selling prints at the age of 13, different things, and started doing that. Then it ended up buying a Prusa Mark III, like pre-ordered it right when it came out and everything, and then got that, had that for a few years. And then COVID hit during that time. I was in high school, so I already had some experience with 3D printing and everything, but I saw, I think it was Pooch from Repcord. He was at Prusa for a little while as well, and he was asking for face shields. And I saw that need and started doing what a lot of both makers as well as industry was switching their printers to during COVID, because we could change and rapidly iterate compared to traditional manufacturing. And that's where that switch flipped in my head of this is what I want to be doing and what I want to study and spend my career doing because of how the technology allows you to iterate so rapidly and change your design, but then also be able to do production with it.
And so as you got to OSU and started kind of combining those interests and working at CDME, like maybe take me through a day in the life, like as you got settled into the lab, as you got kind of were doing your coursework. I mean, for those who are considering university or kind of want to understand kind of what does a modern day manufacturing education look like, what I think OSU has, I think, one of the best models in the country, if not the world, for that. So maybe just walk us through kind of what a typical day might look like, where you're kind of touching some different projects, doing your coursework, things like that.
Yeah, so my undergraduate degree is in mechanical engineering, so I got to learn a little bit of everything with that. We take some material science classes, we take statics, dynamics, all of the fundamentals of how materials interact and how we build things. And the coursework was learned a lot of really the like low level why are things happening, especially like the physics behind everything. And then at CDME, almost every day I was able to really apply what I was doing. I was working during the school year 15-ish hours a week sometimes, but that would change depending on, of course, like tests and everything, where student first, but you're still doing a real job, where I would get to meet with customers. Like Mike was one of our customers while I'm at CDME, and we get to work together on projects with industry, government, etc., on advancing specifically additive manufacturing, where I get to play with really novel materials and different innovations that we do, both like on the machine side, simulations, everything in between, where we get to test them in an environment that is supporting industry directly. And it's not just this one professor with one machine. There's 13 machines that are exactly what you'll see in a shop floor across the country, across the world, really. And that's been the best experience that any undergrad could have, because the second you graduate, you can go hit the ground running into industry. And that's what many of the students have graduated out of that program have been able to do, and either continue in additive manufacturing or other engineering disciplines. We've also had other wide array of degrees outside of engineering, even, where people can go, you can almost be more of like a technician if you want to continue with additive, but there's also people who are writing proposals and are more on the business side. And it's a really interesting center, and something that I think every student should be able to get to have hands-on. And that was what drew me to Ohio State compared to many of the other universities, where you don't get that hands-on experience as an undergrad. It's mostly a PhD student who's doing this research that over 4 years, and it's really interesting to be able to have those experiences right when you turn 18, right after you graduate high school. And it's, I think, something that's really important for many engineers to go out and do, even if your school doesn't have something like that, to go do an internship or go out into industry or other areas to learn about what you're interested in and or what your degree's in.
Yeah. And it just makes it, I always felt that it makes it less intimidating, right? Like you can kind of see how the sauce is made, like even from industry. It's like you kind of get a sense like, oh, I could see myself doing that. Or like you see here the big names or brand name companies in manufacturing, and then like at the end of the day, everyone's just a person, right? Like they're struggling with the same things on a day-to-day basis that you may see in a different context. And I think it's enlightening, and maybe takes a little bit of the pressure off of like just how business works. But also during that time, you got heavily involved in AMUG, right? Maybe walk us through. You were awarded a kind of a big prize on that front. Maybe talk a little bit about that and kind of what that meant for your career.
Yeah. So I was awarded the Guy Bordeaux Scholarship in 2025 at AMUG 2025, and that's for students that are extremely passionate about additive and really trying to learn and change the industry for the better. And that being awarded that has changed my career trajectory greatly. It's one of the most important conferences that I go to now, and it's like family. Every time you go out wherever it was. When I was awarded, it was in Chicago. This past year was in Reno, and it's like a big family reunion. But throughout that, you're getting to learn what everyone is doing in additive. Everyone is willing to share and talk and want to learn from each other on how do we advance our technology as a whole, not just as one company here, one company there. It really breaks down those walls that we have between every company or every university, etc., to really be able to come together in one place for a week and talk and learn from each other on what the next big thing is, or what are we all doing wrong and how do we fix it, because there's a lot of things that I've seen both industry, at university, everywhere in between, that everyone does something a little different, and that works. But it's like there's a lot of that goes back to all like the standardization that we're seeing slowly happen in additive, and how do we get it to be more of a production technology that we're seeing across the board, that we're not having to print hundreds of tensile bars every single build, but we can just go and click print and have the parts right after it.
Awesome. And so you just graduated recently. Want to walk us through kind of what were those last few months like as you're trying to decide what you want to do next? Obviously, for any viewers who aren't listening, they see the DefendAM kind of logo next to you. So maybe talk us through kind of what that is, what you're doing now, and kind of what your initial plans are here in the next few months.
Yeah. So just graduated early May of this year, and was really sitting down with a lot of people who I've met at AMUG and other people in the industry, and sitting down trying to figure out what the next steps are and where I really want to be able to move my career. I've always had that really deep entrepreneurial mindset throughout when I first got my first printer and was trying to be able to pay the printer back off. Essentially, it's how do I continue to grow that and grow within that, where a lot of big industry might not allow me to do something along those lines. So I founded DefendAM in January of this year, mostly focused on defense supply chain and logistics for drones specifically. We built a tool to be able to do some AI analysis on those areas, find gaps, and then depending on what the component is, we plan to manufacture them in-house, as well as partnering with different industries to be able to use local industry that we're seeing, especially in something like a wartime scenario where any manufacturing is going to have to be a defense manufacturer at some point. And so how do we be able to use the mom and pop machine shop down the street to make this small drone component? Or is someone already making a motor that is used for something else but can be used for a drone? And that's really where we're trying to fit in as that gap to connect traditional industry and advanced manufacturing together into one whole manufacturing community, to be able to pivot as needed to the defense industry, to commercial, and be able to eliminate some of those supply chain gaps and overseas reliance that we have.
What's the biggest eye-opening thing that you've learned on that path? More specific to people hear about and talk about the industrial gap and how far behind we are in some of the capabilities to make not just drones but other things in the U.S. But I mean, from where you're sitting, from companies you've seen and worked with, and some of the overall kind of meta challenges that you're looking at, like what would keep you up at night?
It's really that overseas that we exported everything. Really is the big challenge, and that if you get a drone and you say like, hey, what do we manufacture here? It's like nothing. yeah It's every single component. I just saw a video yesterday of DJI released a drone. I think it had like a 300-pound payload bay, and the bottom opened up. I was like, that looks like a Bombay.
Yeah.
They're marketing it as it's like a food delivery drone or something. Is it like that? My brain, the second it went to there, and so like that's really what I start to notice, especially from some of my other past internships where I was at Whiteman and working directly with airmen, was that a lot of the need is in parts. There's a ton of companies designing awesome drones and designing really cool products that can support the warfighter, but then how do we maintain that? They can maybe make 1,000 units or whatever it is in house, but then it's the sustainment, not just only for these aircraft that have been flying for a long time, but now it's going to be for these low cost attritable assets that we're seeing, to be able to even if it is an attritable asset that's not coming back at the end of the day, but something's going to break in the field. How do we maintain that? How do we manufacture either in theater or have enough of a supply chain that it's just an order away through one of the government programs instead of months and months of waiting, especially on a very low cost device.
Yeah. Yeah, and it's interesting. I mean, when you think of 3D printing, right? Like it's frames and maybe propellers and maybe some like engine components for bigger drones and things like that.
Yeah.
But that's not just a drone, right? Like there's the wiring, there's the electronics, there's the controls and the coding and all that stuff. Like, so how are we doing on some of those fronts? Is it any better?
That's the even bigger challenge, especially motors and
Yeah.
boards. We're not. There's a few companies that are doing it at the moment. It's anything that's electronic. We weren't doing in the U.S. Like frames and everything. Yeah, we can make them out of sheet metal. We can make them. We could 3D print them. We have a lot of different manufacturing techniques to be able to do those. But with like the motors, it's a very specific process. There's some innovation on printing motors nowadays and other things, but it's a very labor intensive process or very heavy automation if you're going like full rate million units a year production, then you can automate a lot of it. But when it's the smaller scale, you're changing sizes of motors all the time. It's very, very labor intensive process, and it comes back to a labor shortage, and that we need to have skilled workers that are willing to do manufacturing. And that's the big thing with what I am interested in at like CDME as well, as being able to continue having the students come through and have people like myself be able to learn and get that hands-on experience to get really interested in manufacturing and not just reading it out of a textbook. I think is going to be the way that many universities and many schools are going to have to follow, is to get the students trained both as an engineer but also as a manufacturing expert, if in some of these scenarios, to be able to get the enough people willing to work and willing to be interested in manufacturing to make that a career.
Yeah. And it's interesting too. Like, I mean, there's been it's like a Silicon Valleyation of manufacturing, right? Where like a lot of these big companies, right, are trying to hit big values of like, hey, we make drones or we make all this sort of stuff. But from your vantage point, I mean, I don't see still a lot of like, at the end of the day, like it's got to be like people in factories making this stuff,
Yeah.
right? Like you can sell a story on a spreadsheet or things like that, but once you see a few of these places, you're like, do we actually have this? Like you peel back the onion a little bit, but I don't know. I feel like there's a lot of money going into these, trying to solve some of these, but it may be just a lot of like big bets on things. But like I still think there's kind of a need for those mom and pop manufacturers, what our established supply chain is, who's good at making things, whatever they may be, like just knowing quality, knowing maintenance, having the guy can get a factor or get a machine up and running, whether it's a lathe, whether it's like, you need that guy, right? And so I feel like the things that you guys do at CDME and it's like, you're with the machines, you're you're talking nicely to them, so they continue to work and things like that. But you have to troubleshoot, you have to do the maintenance, and it's not always a straight line.
Absolutely. That's I think the money that is getting dumped into manufacturing is great and is something that we need, but it's a people game. On You need people to learn and truly spend the time with these machines to be able to run them properly. It's not all just click print that everyone sees with their bamboo at home. It's a lot of other work, whether it be material parameter development or even just
contracting, right? Yeah. Like, I mean, even contracting with some of these, the DoD or DOW or whatever, it can be challenging. So.
Yeah.
What about on the flip side? Like, how much do you see 3D printing impacting like defensive drone? Like, I mean, everyone's talking about building drones, but like, I think with 3D printing, it's not like we're the only ones that have that technology, or electronics manufacturing. If anything, we're at a disadvantage on some of those sides. But do you see, I see a lot of like the building of drones and things, but not so much on the defensive. Is there from anything on that side that's
like counter UAS?
Yeah. Like I think the other side of it, right, is like, hey, if a drone is flying at me, what can I do?
Yeah, there's a few interesting things that I've seen lately. Is some like directed energy, very high power laser, which is similar to what we're doing in the 3D printing world. We're melting metal, but it's a little bit different scale with that. That is one of the ways that there's an overlap, especially with like the cost of chips going up and down a lot lately. That directly drives the cost of lasers. Like, lasers were going down and down slowly with like Moore's law, but then now we're seeing them go back up because the chips to drive them has gone back up. So and that's because of AI, but then also with the directed energy side, that you need really high power lasers. So that's another whole industry that could be impacted by it. There's a few other things that I've seen, especially like counter UAS drone. So you're still building another drone to go attack it. So same thing as building a standard drone that you're trying to make the frame, but you're going very heavy typically on those, so you can get the impact that you need, the actually have the force. You can go fast, but if you don't have enough force behind it to go, and you need the mass to be able to do that, that's another very interesting area. And then there's a lot of other ground options that we've seen. There's some new ammo coming out. I think SOCOM just released it. It actually seems like there is some examples of it already. There was a few things that I've seen where it's a frangible 5.56 NATO round that would go in like a standard issue M4, and they're able to kind of get like a shotgun shell like pattern, but much higher velocity, so you could track a drone like as if it, like what we're seeing in Russia and Ukraine, that there's a guy riding in the back of a truck with trying to shoot the drones down so that they're not getting hit by the drones. Is I think how some of the warfare will change. I think the U.S. isn't going to be playing that small game as much, but if we are fighting a boots on the ground war, that it's going to be what we're seeing is a lot of those small, extremely low cost drones.
Sure. And so with DefendAM, I mean, what as you kind of extrapolate out, you're starting your next academic program at OSU, and what do you hope to kind of continue to do with that, and being an entrepreneur, being kind of in academia, like how are you planning to spend your next the 24 hours a day you have in this? Like what sort of partners, what sort of things are you looking to do to kind of continue to build the business and continue your education on the AM side?
Yeah. Sure, my days will be very busy. A lot of what I've been doing over this summer after graduation has been trying to build out those partners and that industrial base that I can lean on for the to build up that supply chain for drones specifically. And I think there's other industries that can go into very much hand in hand. Especially we're seeing printers being put on that sits very similar NDAA list that the drones are. So I think that'll be another area where analysis can be done and find other manufacturing or other replacement parts, etc., for printers. And then so that's been a big portion of it, is finding those partners that are willing to work with us on manufacturing and building the components of drones for things that we're not planning on doing in-house. And then starting my PhD in the fall in industrial systems engineering, focusing on manufacturing. Don't know what my research will be exactly yet. I know I'll be continuing my research on some of the support strategies and support removals that I did during my undergrad. And that was one of the things that hoping to publish by the end of this year, to be able to share with the additive community on how do we improve that post-processing time that we all know and love, to be able to make it really that lights out experience that we all hope for with additive manufacturing.
And so talk maybe a little bit about like what have you thought about for your own production facility, like your own facility you mentioned a few times, like what sort of capabilities, what's your kind of strategy for starting that out?
Yeah, so the plan right now is mostly polymer for prototyping and like especially test fitting different things, repairs, and then looking at other options of polymer additive for in-theater manufacturing to be able to deploy if in the event that we need to be able to maintain these assets while they're in the field. And then probably go with some metal additive as well, to be able to get, especially for turbine engines and other components like that. I think will be something that would probably be more down the line with year 2, 3 with the business, especially that we're such an early phase of everything. Depends on how we can lean on that supply chain at first, and then whatever ends up being those big gaps is where I think we'll fill. One of my good friends actually just started an additive company, and he's doing almost like a send cut send, but for additive.
What does that mean?
So send cut send, where it's a company where you can upload anything that's sheet metal essentially, and you can get it within like the next day or two, and it's very inexpensive and very fast on what they do. And that's his goal with this company, is to be able to do the same thing. And it's called Atomic Factories, and seems like he's doing it. He's been able to drop the cost of additive parts almost tenfold. And it seems like it'll be one of the next waves of additive, is parts as a service, really, is what the focus is on. But I think that'll be a very good partner to have, and some ways that we'll probably lean on that for metal additive if need be, especially within as a Ohio company and local is perfect, because you can get the parts as fast as possible without having to go through those months of contracting or things like that.
So just a couple last questions. I mean, when you were working with us last year, we visited a handful of South Bend manufacturers in the Mishawaka, Indiana area. What's your take on existing companies bringing in that technology versus kind of the like newer companies like yourselves, or the one you just mentioned, kind of more focused on specialty production like additive? Do you think where do you think you'll see the biggest ramp up with either of those business cases, like people bringing in additive to companies, or more kind of external companies like yourselves, like just being an AM first? Yeah,
I think so. Like the more traditional manufacturing, or even if they are advanced manufacturing but not using additive, I think that the biggest thing is tooling and being able to create your own jigs and fixtures very rapidly. is something that every machinist spends a lot of time doing. So if you can create a custom fixture within a couple hours and have it click print, you have it overnight. I think that's a big change for many traditional machine shops, and that would be something that I think could speed up production across the board for many of them, and as well as prototyping. Instead of going and creating the fixture and creating either a tool path, or if you're manually machining, like spending hours out machining something, being able to create a prototype out of a polymer to make sure that that part actually fits and is real, is I think a great thing, as well as it allows you to figure out how you are actually going to machine it, because in a machining process you only have certain angles and different tools that you can do. So if you have the physical one in your hand, you can kind of look at, okay, I'm gonna set up this way, then we'll have to rotate it, instead of getting that CAD goggles almost when you're on the screen. And it's sometimes difficult to be able to really know what angles or what dimensions and everything. So I think that's a big plus for many of those, as well as being able to switch production very quickly. So if they brought in a metal machine or a polymer machine, if they were traditionally an injection molding house or something, being able to do some production prior to tooling, I think is extremely beneficial, as well as if they're having to rapidly iterate. There is that curve of where additive and then where like something like injection molding goes, but that if you're under that point of, I think it's like 50,000 or 60,000 units typically, if you're under that point a year, additive works for you, and you can rapidly iterate those if you need to, and you're not tied to this one tool that's sitting in your injection molding machine only running one part. You could also run other parts with it, or another customer needs something, you can maybe throw it in, fit it into the build if something comes up. And so your production line is extremely flexible with additive compared to other manufacturing techniques.
Awesome. So last question, more of a fun one. I mean, you know it. So I've asked for the last kind of couple of years our guests kind of to recommend a book or a podcast or something to kind of that has been inspiring to them, or kind of given them some knowledge about what they're doing now, or kind of inspiration. But what would be on your list that we can add to the end of the year book or podcast, 3Degrees discussions archive?
Oh, that's a tough one for me.
Or your favorite book that you've read recently?
Yeah, my favorite book by far is The Martian. That's the one that it kind of all goes back to being able to make with what you have, and that's I think where we are right now with the manufacturing environment. So being able to kind of see that in a light of, oh, we're on Mars and everything goes wrong, and how do we make do with what we have and what technologies we have. So I think that's that'd probably be my recommendation. And if you don't want to read the book, there's always the movie, which is always another good option for you.
Andy Weir. Hunter and I are actually reading Project Hail Mary right now by the same author. So
nice. Yeah,
I've read it before. He liked the movie, so we're reading the book now. So
yeah, I read that. It was good, and I just started the movie actually yesterday. So
it's a bit long.
yeah.
So awesome. Well, Justin, thank you so much for joining. We'll put all the links to DefendAM and all the stuff that you're doing at CDME on the site. So thanks again.
Awesome. Yeah, thank you.